Hi everyone. If everything is going well, this will be the last video from TA, and the main content for this video is about Taylor expansion and Maclaurin expansion. So it will be correspond to the week 16 in your lecture note, and we will do some concept and exercise, and at the end we will do the problem 4 in homework 16 together. Okay, so let's get started. From the first topic will be Taylor theorem. So if we say our f of x has a power series expansion at a, okay, then it must be in the form that f of x will equal to sigma our n from 0 to infinity and our f with n times derivative. So this will be n times derivative. You plug in our a, because now we are expansion at a, and subtract by our n factorial times our x minus a with a n power. So notice that when we say we want to expand some function, it is important to mention that where do we expand at. So if we expand at 0, we later will talk about it will be Maclaurin series. So if we expand at different real number, you need to mention that. Okay, so we say that the series is called the Taylor series for this function at a. Okay, so it is all important to say when do we expand it, where do we expand it. And when our a equal to 0, when we expand at 0, we call it Maclaurin series. So our Taylor series at a equal to 0 will equal to Maclaurin series. Okay, and also the second point, our polynomial Tn, this one, this is kind of the definition, is that when we expand it, it will turn into the sigma, our n from 0 to infinity, our f with k's time derivative, and we plug our a inside and subtract by k factorial times x minus a with a k power, and will be the nth degree Taylor polynomial of x, our f of x at a. So notice that unlike the Taylor series, our polynomial will be infinite term. So our n is from, our k is from 0 to n, okay? So our k from 0 to n. So we will say it will be the nth degree, because now this is a finite term, okay? So this is finite. When we say it's a polynomial, it will be a finite term, and the series will turn into an infinity term. Okay, so now we talk about some elementary function, the Taylor's expansion of it. Okay, so the first one will be 1 over 1 minus x. So we know that it will equal to the sigma n from 0 to infinity and x with n power. So it would be 1 plus x squared plus x cubed. And our radius of convergence will be, in this situation, our r will be 1. Okay, so this is one you should keep in mind. So this will be commonly used in this section. And the second will be e with the x power. It will equal to sigma n from 0 to infinity and x with the n power subtract by n factorial. So this radius will turn to infinity. Our radius of convergence will be infinity. And sine, cosine, so notice that this one, because we know that our sine is a odd function, right? Notice that when you expand it out, it will also be an odd function. So you see that there's a 3 power, 5 power, 7 power. Okay, so when you plug in sine minus x will equal to minus sine x. Okay, and the fourth will be our cosine. So similarly, our cosine will be even function. So this will also be an even function, because you see that you see a square, you see a 4th power, you see a 6th power. Okay, and both of the convergence of radius will be infinity in this situation. Okay, so the fifth one will be our arctangent. So our arctangent will be like this one. So I think there's just no need for me to say about it. You just look at it, and our radius here will be 1, okay? And the sixth will be our nature log, 1 plus x. So also be like this, and our radius will be 1. Okay, so 7 will be 1 plus x with alpha power. So we say this one. We return to the sum sigma n from 0 to infinity, and alpha choose n. So this is called alpha choose n, and times our n x with n power. So we know that our alpha choose n will be C in permutation and combination in high school. So it will be the combination of alpha and n. Okay, so it will turn out to be, you can say our alpha factorials subtract by n factorial, and alpha minus n factorial. So it turns out to be your alpha minus 1 times alpha minus 1 times alpha minus 2, all the way to alpha minus n plus 1, subtract by your n factorial. And these are called binomial coefficient. Okay, so this will be binomial coefficients. And our radius of convergence will be 1 in this situation. Okay, so these are the 7 elementary functions that you should keep in mind at the best situation. Okay, so we have talked about 7 elementary functions, right? But if you accidentally forget our arctangent or our nature log or our e with x power in the test or when you're doing homework, how do you derive it? So this actually can be derived from the other 4 elementary function. Okay, so now we look at it. So let's recall that our arctangent derivative will be 1 over 1 plus x squared, right? So now we want arctangent. So we integrate our 1 over 1 plus x squared, and with respect to x, so it will be dx. And you see this one, 1 over something. So you turn back to the first one. You see the similar form, right? So you change our minus x to positive x squared. So by our 1, we can turn into the integration of sigma minus x squared with a n power dx. And you can turn out to get n equal to 0 from infinity. We take our minus 1 out, and our x was 2n and dx. Okay, so we need to integrate it. So at the end, what we got is n from 0 to infinity and minus 1 with the n power. Here x is 2n plus 1. You subtract by a coefficient 2n plus 1. Okay, so you see that this one is identical to your arctangent here. Okay, so if you forget how the Taylor expansion of arctangent looks like, you can just integrate 1 over 1 plus x squared. Okay, so the second one is nature log. When you forget it, you can recall that when the differentiation of the nature log 1 plus x will be 1 over 1 plus x. So similarly, we can integrate it and just plug in also by 1. Okay, so this is also by 1. Okay, so by the first elementary function, we can turn into minus x with a n power n. We take our minus 1 out, and x with the n power dx. So it turns out to be n from 0 to infinity minus 1 with the n power, and you subtract by n plus 1. x with n plus 1. Okay, so if we change our n from n prime equal to n plus 1, it will turn into sigma from n equal to 0, n prime equal to 1 to infinity, and your n prime minus 1, and times your x n prime, subtract by n prime. Okay, so this will be identical to in front of here. Okay, so you just change n prime back to n, so you will get the same answer. And actually, this is still just different from here. This one, start from 0, start from 1. So you can choose any one you want to use, corresponding to the situation you encounter. Okay, so the third one will be our exponential with the x power. So our f of x will be ex. So for this situation, we start from the definition, okay? So the definition, we know that in here we see the definition of it, right? So it will be f with n-time derivative. You plug your a. So now you are in Maclaurin series, so your a will be 0. So you plug in 0. And you notice that no matter how many times you differentiate ex, it will be ex, right? It will be itself. So all the f of n will be equal to ex. So when now we are in Maclaurin series, you plug in 1, but all the coefficient will be 1. So for Maclaurin series, your ex will equal to a summation of n from 0 to infinity. And your f with n times derivative in the 0. So this will be 1. This will be 1. Okay? So what I get at the end is summation n from 0 to infinity. 1, you can just take it out, and x with the n power over n factorial. Okay, so the 3 expansion, when you forget it accidentally, you can try to derive it by yourself. But if you forget the expansion of this one, this 3, okay, or this 4, I don't know, you better pray for God, okay? So don't forget this 4, okay? So if you forget this 3, there may be some situation or solution you can find for. Okay, so remind that never forget this one, first one. Sine and cosine is easy to recognize, and the last one is this one, the 1 plus x with the alpha power. Okay, so now let's do some exercise. So the first one, our f of x will equal to e with x power minus e with the minus x power, subtract by 2. And now our alpha, our a is at 0, so it will be Maclaurin series. So we started from, we know ex, right? And we know e with the minus x. We know how to expand it by 2, right? So it will be the summation of n from 0 to infinity. Summation of n from 0 to infinity. Here get your x with the n power, so try by n factorial. And also n from 0 to infinity, get your minus x with the n power, so try by n factorial. Okay, so before we start, if you want to exercise it, do exercise by yourself. You can just pause the video at here, and you can check it after I solve it, okay? So this will be 1 plus x with 1 factorial, x squared plus over 2 factorial, and so on. And this will be 1 minus x over 1 factorial plus x squared over 2 factorial, and minus x cubed over 3 factorial. Okay, so what we So because now we want to minus, right? So we minus this 2. Minus. So what we get is what? And we subtract by 2, okay? So our f of x in here will be equal to, because this subtract by this will be something out, right? This one. So you get the term only in x with over 1 factorial plus x cubed over 3 factorial and x with 5 power over 5 factorial and so on. And at the end, you can write it as sigma n from 0 to infinity x with 2n plus 1 power over 2n plus 1 factorial. Okay, so this will be our answer. And you can applicate it to when you want to find, when you want to find e with minus 1 over e, subtract by 2. So this will be, so if you want to find this one, okay, and it will be our f of u block 1. So f of 1, and you notice that your xb1, it will be the sigma, our n from 0 to infinity, 1 over 2n plus 1 factorial. Okay, so this is some application you can use for this answer. Okay, so the second one will be our f of x equal to ln x, latent log x, and we want to expand it at a equal to 2. Okay, so we want to we want to make this one. You can say we want to make some x minus 2 term in the solution. So our f of x equal to natural log x, because we want x minus 2, so we change it to x minus 2 plus 2, right? And we know that when you because we know in here what we got is natural log 1 plus x, 1 plus any term, right? Because now we have 2, so we want to take our 2 out, so it will be natural log 1 over 2 2x minus 4. Take our 2 out, so like this, 1 plus 2 over x minus 2 over 2, it will be like this. And we can take our natural log 2 out and plus this one. Okay, so we all know how to expand this one, right? So this one, you just plug in this one, the same answer. So at the end, you will get natural log 2 plus summation n from, I think we use n from 1 to infinity. Okay, n from 1 to infinity minus 1 and minus 1 power, and just substitute your x with minus 2 over 2 with the n power. Okay, so let me just look. Okay, and you can simplify it by taking 2 out. So n from 1 to infinity, here minus 1. Get your 2 with n power out. Get x minus 2 with n power. Okay, so the idea for the second question is, because we want to make x minus 2, so we try to make it out. But when we make it out, we find a 2 here. We don't want this 2, we want it to be 1, right? So we subtract by 2 out and take our 2 out. So in here, at the end, we know how to expand this one. Okay. So the third question, our f of x equal to sine squared x. Okay, so our now is Maclaurin series because our a is 0. So how to do sine square? We know sine, and we know how to expand cosine, right? But you know that you just square this. If you just square this one, is just too difficult or too complicated. So what we do is what? Sine square will equal to 1 minus cosine 2x over 2, right? So as long as you know how to use this will be really easy. And so it will be, f of x will be 1 over 2 minus 2 over, so let's see, cosine, and from 0 to infinity, minus 1 x power, and from 0 to infinity is 1. Okay, so you should recognize this in the test, but I forget it all, so let me just look at it. Okay, so 2n, and now you're exchange 2x 2n, and you can simplify it by yourself. Okay, so I leave it to you. Okay, so the third one will be some computation about trigonometry. So you're just using your sine and cosine to find out how to expand another trigonometry. Okay, so the third one, f of x will be 1 over x squared plus 2x. And we now want our expansion at -3. So we want to make this one, right? We want to make x plus 3. Okay, so how do we do that? One of the way to do this, some of you may think of this one. I don't know if anyone think of this one, but actually this, you don't know how to expand this one, right? Well, you got a -1 here, and actually you cannot make an x plus 3 here. So another way is we subtract our x out. Okay, so a very important skill in this session is when you see this term, the kind of this term, you know, to change it into this one. Okay, so this is the key point. You know how to turn into this one, and when you know how to turn into this one, everything becomes simple, because now we can do the things we want, right? So it's +3, -3, and -1 over x plus 3 minus 1. Okay, so at the end, this will be easy because you know this one, you know the first point, right? So now we get 1 in here. We get -3, -1 and -3. So what we do is subtract by it out. So we subtract our -3 out, so it will be 1 minus x plus 3 over 3. And a -1 out, so this becomes plus 1 minus x plus 3. Okay, so now you know, you just plug in the formula, you know how to expand it, and the last step is just make it more beautiful. Okay, so I think that's not too difficult, so I leave it to you. Okay, so just some similar concept in this part. Okay, so in question 2 is just know how to make our x plus 3 in the calculation. Okay, so the question number 5. So this will be 16 plus x squared times our 1 minus x, and the whole is 1 over 4 power. And now it's a Maclaurin series, and I wanted to find the first 3 non-zero term. Okay, first 3 non-zero term. So a question like this, actually, it don't want you to find the whole series in the most situation. It wants you to find like the first like 1 or 2 term. So what we do is we split it into 2 terms. Okay, so we turn it into 2 terms like here, like this, and you see these two are similar to the format of this, right? Our number 7. So it's 1 plus x with the alpha power. Okay, so now you have a 1 plus x. This will be okay. You just change your x to minus x. And this you need to subtract by 16, okay? So, alright, 1 minus x with a 1 over 4 power. It will be, just plug your 4 lines. You get minus x with 1 power and 1 over 4 choose 2 with minus x square. And just some non-important term. And 16 over x squared will be, subtract by 16 and it will turn out to be 2 in the side. This will be, I think is minus here, minus x squared over 16 or 4. Okay, and times 1, I think is minus, okay, so 1 minus x. That's x. 1 over 4 choose 1 and with this one. Okay, hope, oh, looks like this. Okay, so got this. And some non-important term. So at the end you'll get 1 minus 1 over 4x minus 3 over 32 x squared. And this will be 2 plus 1 over 32 x squared and some unimportant term. Okay, so want the first 3 non-zero terms, so we times this 2 together. Okay, times this 2 together, and at the end you will get f of x will equal to 2 minus 1 over 2x. So you list out in the order of x0, x1, x2, x3. Okay, so this will be minus 3 over 16 plus 1 over 32 x squared and so on. Okay, so this 3 term will be the first 3 non-zero term. Okay, so notice that sometimes the sum of the term will be 0, then you need to skip it. Okay, so the idea for problem 5 is when it tells you to list out the first like 2 or 3 or 5 term, actually you cannot expand all the series to infinity terms, so you just list out the term that is important. So in this question it will be the first 3 term or 2 term. Okay, so the 6th question will be our f of x equal to secant x and n equal to 0. Okay, so these are some similar situation to our 3rd question. So the main idea will be secant is what? Equal to 1 over cosine. Okay, and I forget to write. This is also, so these are the first 3 non-zero term. For the 3 non-zero term. Okay, so the main idea is secant will equal to 1 over cosine. So just as I said, you cannot actually expand the function, so what we do is using the deviation is we now have a 1, right? Because we know that cosine is equal to what? It's 1 minus 1 over 2 x squared plus 1 over 24 x with a 4th power, right? Let me look. Yes. Okay. So, because we want to know the first three non-zero terms, so we list out the for three non-zero term, but there's actually more term. Okay. But now we neglected it. So our cosine now will be just like this. So what we do is using you have learned in elementary school, right? Not elementary school, but never mind. Get this one in some not important term. So you know how to divide it, right? So it will be this plus x fourth power minus, right? So you get minus 20 this one, and for the first term you need to add in this one. And when you do along, you know that you need to plus 5/24 with the x and x with the fourth power. So this will be infinity term, but you only care about the first three term. Okay. So now our answer would just be 1 plus 1 over 2x squared plus 4 to the fourth power. Okay, so this 3 is the only three term we are care about. Okay, so just a combination about 3 and our 5. Okay. Okay, 7th question. F of x will equal to arc sine x, and now will be a Maclaurin series. So similar idea to our arctangent, because we know the derivative of our arc sine will be 1 over square root of 1 minus x squared, right? So it will actually be this one. So this will be in the form of binomial, right? So we just expand it. So it will be minus 1 over 2, choose n, and minus x squared with the n power. And we simplified it, and now from 0 to infinity, minus 1 over 2, choose n. We take our minus 1 out. Okay, so now we have the derivative of our function in the summation form. So now we need to integrate. Okay, so integrate is not that difficult. You just imagine you integrate every single term. So our f of x will be arc sine and will be your constant, integrate constant, plus, and also from 0 to infinity. So our coefficient will not be changed, and your minus 1 with n power will not change, but your x with 2n plus 1 power, and subtract by 2n plus 1. So then you will get, you can plug in 0 to find your constant c. So, because now we are arc sine, so arc sine 0 will be 0. So our c will be 0. Okay, because you plug your x equal to 0 inside. So now our function will be 1 minus x minus 1 over 2, choose 1. 3 over x cubed, and just some coefficient. And at the end you will get okay, so you can stop at this term. If you want the answer is in sigma form, you can stop in here. Okay, so now we have evaluate our arc sine, right? The 8th question will be the limitation of our sine x times arc sine minus x squared over x with 6 power. So we just list out. Don't think it as too complicated. We don't know. So now look clearly what the answer are being. Just list out all the things you know. So it will be more easier for you. So when we subtract by our sign, arcsine, you can time it yourself. Because in this situation, we want limitation and our x with the 6th power, right? So what we cared about is the term equal to 6th power or smaller than 6th power, right? Because if we have in here, let's say we have x with a 7 or 8 power, and we subtract by our x with a 6th power, we get x and x squared, right? Okay, so it will turn out to be 0 because our x will be 0. So we only care about the smaller or equal to 6th power terms. Okay, so now we list out the first, because our sign will be go to 7 power in the next term, so it will be not important. So we list out the first 3 term, which will be the power less than 6, and our arcsine also we list out the 3 term. So this will be used in our problem 8, right? So when you times it together, you can do it yourself. You'll get x cubed and this. Okay, so we know that now we know the sine x times arcsine x will be this one plus some terms greater than 6. So answer of limitation, subtract by x with the 6th power, and you notice that the x cubed in here and x cubed you will minus out. So at the end you will get limit of x equal to close to 0 and 1/18 with the x 6th power, and the terms with order greater than 6. Okay, and other terms will just be unimportant, so the answer will be 1/18. Okay, so this question is kind of tricky, but just notice that you only care about the terms that with a power smaller or equal to 6. Okay, so you list out up to 6 power or 5 power, because next one will be 7 power. Okay. So the last one, if our f of x will equal to x times arctangent with x cubed inside, I want to find the f with 16 time derivative term in 0. So it will be Maclaurin series. So now this will be quite easy. You just, because now you know how to expand arctangent, right? So do it directly. You'll get x cubed minus x with 4 power and x with 15 power. Because let me look. Because your arctangent will be 2n plus 1 term. Okay. So your 2n plus 1. So now your x with x cubed. So it'll be x cubed and 2n plus 1. Okay, so the first term will be, the second term I think will be 9, not 4. 9. Okay, and the next one will be 15 over 5 minus by, and some term irrelevant. So you get x4 with 16 power, and the only term we are interested in is this term. This term, right? Because we know that our by our definition, our f with 16 times derivative. Subtract by 16 factorial will be in what? Will be in power of 16. Okay, so this will be in the 16th term, and will also equal to what we expand out. Okay, so we subtract by x with the 16 power at both sides. So at the end we will get f with the 16 derivative equal to 16 factorial subtract by 5. Okay. Okay, so now we have done of part of expansion, and a second part will be how to use the Taylor expansion or Maclaurin expansion to do our conversion test. Okay, so when we want to determine the convergence of the first series, so this will be the summation about 1 minus cosine. Okay, so what we think about is cosine x. What? Cosine will be similar to 1 minus x squared plus subtract by 2 factorial plus x4 subtract by 4 factorial. Okay, so now we have 1 minus cosine x, because we have 1 in the front, it will similar to our square part, right? And because other term in the you also get some term in 4 factorial and 1 over square root of n with a 4th power, but here gets n cubed over 1 over n squared in the term and 1 over n, but we know that this will be too small to determine, so this will be the leading term. This one will be the leading term of 1 minus cosine x. Okay, so if we want to use the limit comparison test, we will try to choose our 1 minus n in the denominator. Okay, so you may try to compute 1 minus. Let me try to compute this one. Okay, because we know that the leading term will probably be 1 over n, so the term below it will be we guess it will be not important. Okay, so you can choose to do this one. We want to use limit comparison test. Okay, so the next one, problem 2, will be similar. Now we know that we have this one. We change our n to subtract by 1 over n. Okay, and we change to x, sin x over x, because we want to know the limitation of it. So if we use we expand our sin x. Okay, so also notice that the other term will be not important, and the first term will be subtract out. Okay, so we will choose our first term to be the leading term. So this will be similar to x squared over 6. So we know that we can try our limitation n to infinity, and this is our problem, and subtract by our 1 over 6 times n squared. Okay, so this is some application of the Taylor expansion you can use on doing the conversion test. Okay, so homework 16, which will be in the problem 4. Okay, so I think there's some similar question in lecture notes, and so the part A will be similar. Okay, so let our f of x. So we want to find the Maclaurin series of our f of x. I want to specify the radius of convergence in A part, and the B part, I want to find f with fifth time derivative, and at the end, I want to approximate the arrow. You want to approximate f with 1/2 in an arrow of 10 with the -4 power. Okay, so we start with our first our A part. Our f of x will be from integrate from 0 to x, and we change our term in this. Okay, so this one you will know how to do it, right? It will be binomial term, this one, number 7. So just expand it into a summation. So you turn out to k equal to k from 0 to infinity, and there will be minus 1/2, choose our k, right, and the t squared with a k power, and want a dt. Okay, got right wrong? I think I'm writing it the right way. Okay, and you want to integrate it with respect to t, so you get at the end k from 0 to infinity, and the coefficient, just let it at there. Your t2k will be 2k plus 1 over t2k plus 1. Okay, so this will be the integration, the expansion of our f of x at at a equal to 0, which will be Maclaurin series. And because the second part is want to find the radius of convergence, right? So we know that for the binomial term, know from here, for binomial our r is equal to 1. So this r will also equal to 1. Radius since binomial r equal to 1. Okay. Okay, so this will be the A part. And then the B part, I want to find the f with fifth time derivative. Okay, so just similar to this one, similar to our problem 9. Okay, so you just plug in definition and kind of compare it, and you can find the term. So from definition, we know that f with fifth time derivative will be subtracted by 5 factorial, and it will be minus 1/2, choose 2, and times, because our k now equal to 2, so k equal to 2, because we want fifth time derivative. So what we get is, let me look, 1/5, yes, because we subtract by our x with the fifth power in the both side. Okay, so relatively simple. It will be, let me look, this will be 24, and subtract by, we do compute the choose term, combination term, and this will be 12 times the 9. Okay, so it will be 9, the end. Okay, so the C part, want to approximate the value of f of 0.5 up to an arrow of 10 with the -4 power, and wanted to recognize your f with the alternating series. Okay, so how do we change to alternating series? We first plug in. Okay, so we first plug in and specified it. So our k now from 0 to infinity. Just some same term, and you just put in your 0.5 inside 2x plus 1. Okay, so how do we change it to the alternating series? So we know that alternating series means your sign is changing, right? You get a minus 1, 1. You get a positive or negative alternating. So we don't see something alternating here. So we try to expand it out, okay? So we expand this one, this term. And this term will be minus 1 over 2 times minus 1 over 2 minus 1 times minus 1 over 2 minus 2 all the way to minus 1 over 2 minus k plus 1 this term, and subtract by k factorial, right? And what we can do is take our minus 1 out because we want the minus 1 term for alternating series. So our minus 1 with n power out, with k power. Okay, minus 1 with k power out, and we get 1 over 2 times 1 over 2 plus 1 times 1 over 2 plus 2, and all the way to 1 over 2 plus k minus 1. Subtract by k factorial. K factorial. Okay, so this will be our binomial term. So at the end, we put back to our function. Our f of 0.5 will be sigma our k from 0 to infinity, and just this term plug inside. Okay. Okay, so don't need this one. And don't forget this two terms, so it will be 0.5. 2k plus 1, subtract by 2k plus 1. Okay, so this will be an alternating term. This will be an alternating series. Alternating series. Okay, so let me move this one. So for alternating series, we started this. We take the minus 1 with k power out. So all the other term we can turn into b. Okay, so we can take it as a b with a, let's say bk. Okay, so now we recall the part of alternating series. Okay, so we need to find it converge, so we can estimate the arrow. So in order to estimate the arrow, we need to prove that our bk plus 1 subtract by bk is decreasing. So I'll leave it to you. And our limits to bk equal to 0. Okay, so this will be the recall of our alternating series. Okay, so I'll leave it to you, and at the end, by the arrow for our alternating series, the arrow will be our bk plus 1 term. Bk plus 1 term will be smaller or equal to 10 with the minus 4. Okay, and you can try some number and you know that n equal to 4 works. Okay. So this turn back to the concept of alternating series. You may check out if you forget it. Okay, so I think this will be the whole video for our TA's video, and just notice you that in June 19 it will be our final, and from 9 p.m. to 11:30. So don't forget to attend the online test, okay? And I think we will not meet until next semester, so good luck for the final and hope we can meet somewhere in the future. Okay, thank you.